Yes, hello Vikas, welcome on YourPedia platform and let's start your thermodynamics snap for your final DRDO interview for
Okay,
the post of scientist B.
yes.
Vikas, what is thermodynamics?
So thermodynamics is a process in which we convert disorganized form of energy into organized form of energy in an efficient manner.
So every time we carry out conversion of disorganized into organized, or sometime that maybe conversion of organized form into disorganized.
Yes, sir.
So only
Oh,
the conversion of disorganized form into organized form is a study which we can carry out under this domain, thermodynamics.
yes.
Hello.
Yes, sir.
So what you mentioned, because that is only can, like, suppose if some kind of work is converting into heat, so that is not going to come under thermodynamics.
So that will come. Heat is a lower grade and lower grade to higher grade uh, that comes
So
under
why heat
thermodynamics.
is a low grade energy and how you can say work is a high grade energy?
So, because sir, complete conversion of heat into work is not possible as per the second law of thermodynamics. So
Okay,
some
can you tell
amount
me
of
more about that? Why the complete conversion of heat into work is not possible?
uh,
Good.
there is some amount of energy that is to be released to complete the cycle, sir. So that that amount of energy less in the work done according to the second law of thermodynamics to run a cycle.
What do you understand by conservation of energy?
Yes, sir.
What do you understand by conservation of energy, Vikas?
The conservation of energy means energy neither be created nor be destroyed. It can be converted into one form of energy into another form.
I just suppose there is a, for example, let's take an IC engine in which we are carrying out combustion of fuel, okay,
Yes, sir.
and we are liberating some energy.
Yeah.
So how you can write the first law of thermodynamics for that combustion reaction?
For combustion reaction, sir.
Yes.
Hello.
Yes, yes, Vikas.
Okay, sir. Mm, Sir, as per the first law, dq, the amount of energy that comes from burning of fuel, dq, uh,
Hmm?
some part of it will uh, transfer into the work done by the force apply on the piston and remain that it will exhausted. So dq is equals to du plus dw. And hello.
So that same equation we can use for combustion also. dq equal to du plus dw.
dq equals to
So what do you understand by spontaneous processes?
so spontaneous process uh, which takes very less time and happens all of a sudden, and there is no external heat input or required for instantaneous process.
So can you give me one example of a spontaneous process and one example of a non-spontaneous process?
Spontaneous process like sir, melting of ice.
Mm-hmm.
Melting of ice is a spontaneous process.
Okay. Give me one example of non-spontaneous also.
Non-spontaneous like in which sir heat is input like
Hmm?
so
So all processes are spontaneous, but there are some processes which are non-spontaneous.
yes sir. Burning of fuel sir, or like wood.
Burning of fuel or wood.
Sir.
So how it can be non-spontaneous?
So it is spontaneous.
No, I asked you to give example of a non-spontaneous. Mhm.
It's a rusting of iron, sir.
Rusting of iron.
Yes, sir.
Say, convince me how it is non-spontaneous.
So it takes so long time to rust, sir. Like
So we need to give some kind of energy to carry out that process, or naturally it takes
sir,
without any
delta
external
G, sir.
gradients,
Delta G is,
external.
for spontaneous process, sir, delta G is negative, sir. That so
Good.
the spontaneity.
Uh-huh. Give
And
me any
so
example where delta G is positive.
delta G positive, sir. Delta G is positive is not possible as far. Delta G zero, delta G can be zero or negative, sir.
Zero negative. So
Yes,
non-spontaneous processes are saying that those are not possible.
non-spontaneous for non-spontaneous processor it is zero,
Mhm.
and for spontaneous process it
So
is negative.
you know any example of non-spontaneous process or not?
Yes, sir.
There are so many processes which actually for carrying out some of the processes we need to give some work. There are so many examples you can get,
Yes, sir.
like refrigeration.
Yes, sir.
Refrigeration heat transfer takes place from lower temperature to high temperature. How? With some work input. So
Yes,
that
sir.
is not a
External work
spontaneous
input.
process.
Yes,
Transfer of heat from high to low, that is a spontaneous process. But
yes,
transfer of heat from low to high, that is a non-spontaneous process.
yes, sir. Yes, sir.
Okay. What is entropy, Vikas? And what is the significance of entropy in thermodynamics?
Sir, entropy degree of, sir, randomness or disorientation in a molecule. Uh, that is the entropy, sir. That is measure of entropy. Higher the randomness, sir, higher the entropy.
Give me significance of entropy. What is the significance of entropy in thermodynamics?
Yes, sir.
Mhm.
Sir, we have a heat at higher temperature, then for that we can say entropy change will be less, and that is there more available energy is there. And if the same amount of heat is at a lower temperature, then in that case entropy change will be more. So that is the less available energy in the system.
Can you tell me the difference between energy? Okay, energy, exergy, and energy. ANERGY.
Yes, sir. Energy.
Yes, go ahead and tell me the difference between
Sir,
energy,
maximum.
exergy, and energy.
The energy is the maximum useful work that can extract, sir, in a process is the availability, or in a cycle, if it is in a cycle, sir, then that it is energy, energy.
Mhm.
Yes, sir.
You know how they are related? Energy, exergy, and energy. How they are related?
Both three are similar, sir. Energy, exergy.
Mhm.
Energy and energy or energy and exergy are same, sir. It is for a cycle and it is for a single process.
So, according to first law of thermodynamics, energy is conserved.
Yes, sir.
So, exergy is also conserved in a process or in a
No, sir.
cycle.
First law of thermodynamics, energy of an sir, closed system is conserved, sir.
No, if we'll take a
Cy- cy-
cycle,
cy- cyclic, the cycle
so for
completes
cycle,
energy.
energy is conserved.
Yes, sir.
So, exergy is also conserved in a cycle, complete cycle.
Sir, it depends upon the, sir, ambient temperature, sir. If the ambient temperature is low, then in that case we have the more amount of availability, sir. So in that case we get the more energy. And if the ambient temperature or temperature is high, then
No, fine,
in
fine.
that
That's
case,
fine. That's fine. I'm just asking you, exergy is conserved or not?
Sir, for a closed cycle.
Yes, yes.
Hello.
Yes, because for a closed cycle.
So for a closed cycle, if the temperature limit means higher temperature and lower temperature are same, then exergy will be conserved. Sir.
So if a system, if a engine is operating between some constant source and sink temperature, then
Yes, sir.
exergy is conserved in a complete cycle.
No, sir. It actually, sir, it depends upon the if the temperature outside, that is, let us, sir, the temperature at which it is rejecting heat is sink temperature. Outside temperature is low than sink temperature, then we can more available energy than actual work done.
So that you are telling through Carnot theorem. Obviously, the temperature difference between source and sink is higher, more is the efficiency. But I have
Yes, sir.
not asked you that because मैंने ये तो आपसे पूछा ही नहीं है. I am just asking you, energy is conserved. You mentioned both are same. So how they are same? You mentioned energy is conserved according to first law of thermodynamics. So I just asked you, exergy is also conserved. You have not answered actually that particular question. You can tell me, sir, yes, it is conserved, or you can tell it is not conserved, sir, or you can tell, sir, I don't know.
Just a minute.
Mm-hmm.
So 1 minute. Conserved, sir.
Then what do you mean by degradation of energy? Second law tells us a real process takes place in the direction of degradation of energy. You know about that statement? You heard about that statement, Vikas?
Yes, sir.
Second law of thermodynamics tells us about degradation of energy. It tells a real process is going to execute in the direction of degradation of energy. And what do you mean by that degradation, Vikas?
So degradation of energy means that comes in picture when in actual when friction comes inside the system, sir. So due to the friction, irreversibility increases, system irreversibility increases, and in that case, sir, entropy generation takes place within the system due to which, sir, degradation of energy occurs.
No, what do you mean by degradation? Fine.
Degradation
Again,
means,
I'm not asking the reason about reason for degradation. You're telling me the reason of degradation. You're telling me the reason cause of irreversibility. But I'm asking you, what do you mean by that? Degradation of energy. Energy is conserved, then what is degrading? Energy is conserved, suppose we are converting heat into work.
yes, sir. Sir,
Okay.
higher grade energy degradation, sir.
Okay, for example, in a heat engine, in a typical heat engine, maybe suppose some IC engine, we are converting heat into work.
Okay, sir.
Okay, so we are converting the chemical energy of the fuel into heat energy, and then that heat energy we are converting into the shaft work. So
Okay.
low grade energy we are converting into what? High grade energy. Okay,
Yes, sir.
but in that case also degradation is taking place. Where is the degradation taking place? And what do you mean
Yes.
by that degradation?
So here, sir, maximum work that we can get in actual it is not getting, sir. That is the degradation.
Fine. So it means exergy is decreasing.
Yes.
Because that whatever work potential we are losing, whatever work potential we are losing, that is the irreversibility. W max minus W actual.
Yes, sir.
It means we are losing work.
Yes.
It means exergy is not conserved. We are going to lose the exergy in every real process.
Yes, sir. For real process, sir, loss of exercise.
Energy is conserved for all real processes. So that is also not conserved for real processes.
Yes, sir.
Energy is conserved for real or only for theoretically some kind of reversible processes?
No, sir. Energy is conserved. Actual energy is conserved, sir. For your
For
process
all,
also.
reversible, irreversible, any process.
Sir, if we calculate all type of energy that are leaving the system, if we talk everything of energy, then energy is conserved, sir. Irreversible, for including irreversible and reversible both energy.
Okay. Okay. Because let's take an example of a electric fan, ceiling fan, typical ceiling fan.
Okay, sir.
Can you carry out some kind of first law and second law analysis of that ceiling fan? Maybe you can consider a 50-watt ceiling fan, 50-watt का एक ceiling fan है, and I
Yes,
just
sir.
allowed you to carry out some kind of experimental analysis on that ceiling fan. But आपको क्या करना है? आपको उसका first law और second law analysis करना है. तो what you will, what kind of analysis you will carry out? What you will measure to carry out your first law and second law analysis of a ceiling fan? Go with all suitable assumptions. Okay.
Yes, sir. Sir, 50 watt, sir. Fan what is? Hello.
Yes, 50-watt ceiling fan, Vikas.
Okay, sir. Sir, first electrical energy, there will be some losses, sir. In conversion of mechanical energy, sir, the rotational unit, like sir, in motors, let's say motors, sir. So DQ, sir, the system energy and DW, sir, work done. So, sir, what if we have energy, sir, DQ, let's say 50 watt, sir. So there is friction loss in terms of resist in terms of friction, sir. So some energy will lost there, and further, sir.
अच्छा, how you will measure? Okay, let me simple it for you, विकास. आप मेरे को बताओ, फैन है आपके पास.
Yes, sir.
And now I am not giving any data to you.
Yes, sir.
बस एक फैन है. All experimental instruments you are having, you can measure the work input, the fan, you can measure all other things also, whichever you want to measure. मेरे को बताओ आप उसका irreversibility कैसे find out करोगे? How you will find out the irreversibility of a ceiling fan?
फैन का सर?
हाँ, yes.
सर फर्स्ट ऑफ सर उसका जो आरपीएम से रोटेट कर रहा है उसका सर टॉर्क इनटू whatever is the torque and rotational speed, that we will get the power, sir. And actual input, sir, we have the actual input and we have the output, sir. So difference between these two, sir, we can get irreversibility of fans.
And what about first law and second law efficiency, Vikas? How you will calculate the first law and second law efficiency of fan?
Sir, for सर फर्स्ट ला सर वो आउटपुट बाय इनपुट सर.
हाँ ठीक है.
And
so what is the output?
Output sir rotational power in
shaft power. The shaft power मिल गया, that's the output. ठीक है. What is the input?
Input sir electrical power sir.
अच्छा, आपको क्या लग रहा है? Fan is like a motor. Final output of the fan is the shaft power or the change in kinetic energy of the air?
Sir, that is the outside of fan sir. मतलब fan का तो वो बाहर है ना सर. तो fan का if we calculate the for that, fan only for that, fan only.
What is the output to us? What is the output to us? The shaft power which we are getting, that is the output to us.
The shaft power creating velocity in air, sir. So
yes. So what is the output? What is the output? Output is a change in kinetic energy of the air.
Change in yes sir.
हाँ.
Sir, पर सर आपने बोला सिर्फ फैन के कैलकुलेट करना है.
हाँ.
तो अल्टीमेट पावर सर वी हैव द वेलोसिटी
और फैन मोटर, अगर हम मैटर की बात करेंगे that is right, but if you consider entire system, fan as a system, then the output will
Yes,
be
sir.
change in kinetic energy of the
Yes,
air.
sir.
Like the pump. What is the output of a pump? The shaft power.
Yes, sir.
For a,
Output of
for a
pump, sir.
pump, the output is shaft power or what?
No, sir. Velocity of fluid, sir.
We raise the
Velocity of
potential energy of the water.
potential energy as well as velocity of
Yes.
fluid.
Utilizing what? Utilizing the mechanical energy, utilizing the shaft power.
Yes, sir.
तो एक्चुअली उसमें अपने को दो पार्ट अलग दिख जाते हैं, मोटर एंड पंप. तो मोटर
Yes, sir.
कन्वर्ट्स इलेक्ट्रिक एनर्जी इनटू द शाफ्ट एनर्जी, shaft power, and pump section converts the shaft power into the
Fluid energy.
increase in potential energy of the air. Water. Similar
Yes, sir.
kind of thing is there in fan also. Fan or blower, what we are doing? We are converting electrical energy into the mechanical energy and then utilizing that mechanical energy to raise the kinetic energy of the air. नहीं?
Yes, sir.
तो मेरे को ये बताओ इसका सेकंड लॉ एफिशिएंसी कैसे कैलकुलेट करोगे? And now just consider the output of the air, means the change in kinetic energy of the air as the output.
Yes, sir.
ठीक है, फर्स्ट लॉ तो ठीक है आपने बता दिया, चलो we can measure the mass flow rate of the air. Okay, we can measure the mass flow rate of the air and we can assume the stagnant air is there in the room. So whatever velocity air is coming up with, that through that we can calculate. We can consider initial kinetic energy 0. So half m dot v square, that is the final kinetic energy, and that is only the change in kinetic energy. Fine. So that we got, and input is also known to us by calculating the voltage and current. So through that you will get first law efficiency. Now tell me how you will calculate second law efficiency, Vikas. That is my last question to you.
Sir, second law efficiency, sir. Actual by absolute, sir.
That is for a work producing device. W actual by W maximum. वो तो इंजन के लिए ठीक है. But the same expression we cannot use for a kind of refrigerator or maybe a fan or other systems. Second law efficiency is W actual by W maximum only for work producing devices. चलो ठीक है विकास, मैं आपको अभी फीडबैक दे देता हूँ.
Yes, sir.
देखो विकास, वैसे तो आपका अंडरस्टैंडिंग ठीक लग रहा है. You know, in DRDO actually they are going to ask you some linked question. तो थोड़ा सा आपको माइंड अप्लाई करना पड़ेगा. They will allow you to stand in front of board also. अभी आज थोड़ा सा आप नर्वस थे, अब बहुत ज्यादा कंफर्टेबल नहीं लग रहे थे. ठीक है, अभी तो there is only one person, one mentor interacting with you. In DRDO there may be 8-9 scientists in front of you and they will allow you to stand in front of board. तो वहां पे तो आपका नर्वसनेस बढ़ सकता है. थोड़ा और कंफर्टेबल होना है आपको विकास, ठीक है. So and try to recall whatever you studied. That expression I got, your understanding is there, but I don't know where you are confused at some of the points. Exergy is always going to degrade. Any real life example you can take, always exergy is going to degrade. Degradation, a real process is possible always in the direction of degradation of energy. Degradation means what? Degradation means loss of available energy.
Yes.
So in all real processes, available energy is going to decrease. For example, if you take water in a dam, what is the available energy of that water in dam? That is huge. What is the available energy of water in the nozzle? That is lesser than that. What is the available energy of the work which you are getting through the turbine? That is further reduced. What is the available energy of the electricity we are generating in the generator? That is further reduced. What is the available energy of the electricity we are getting at our home? That is further going to decrease. Are you getting? So in all real processes, exergy is going to decrease. Okay, that is known as degradation of energy. Fine, Vikas?
Yeah.
So exergy is going to decrease, entropy is going to increase, and energy is going to conserve constant. Total energy is going to remain constant in a real process. तो real process जब भी होता है तो entropy आपका बढ़ता है, इसका यूनिवर्स का. एक्सर्जी आपका घटता है, मतलब अवेलेबल एनर्जी हमेशा घटेगा और एनर्जी कंजर्व रहेगा, whether it is a reversible process, irreversible process or any process. First law of thermodynamics is applicable to any process.
Any process.
तो वो कॉन्फिडेंस आप में नजर आना चाहिए कि हाँ, yes, clarity, that clarity you need to show. थोड़ा सा आप कंफ्यूज हो गए थे मैंने asked you about that. ठीक है, अब देखो सेकंड लॉ में आता हूं मैं. सेकंड लॉ एफिशिएंसी क्या होता है? इट इज अ रेशियो ऑफ द एक्सर्जी यूटिलाइज्ड टू द एक्सर्जी एक्सपेंडेड इन ए प्रोसेस. कितना एक्सर्जी किसी पर्टिकुलर प्रोसेस के एंड पे कितना एक्सर्जी है आपके पास, एंड हाउ मच एक्सर्जी यू आर पुटिंग इन दैट पर्टिकुलर प्रोसेस. इनपुट के रूप में कितना एक्सर्जी दे रहे हो. सो एक्सर्जी यूटिलाइज्ड बाय एक्सर्जी एक्सपेंडेड, दैट is the general definition of second law of thermodynamics. Okay, now for a heat engine, for a work producing device, how much is the exergy we can utilize? That is a W actual. How much exergy we invested? That is W maximum. That is the work potential we invested initially. That is the work potential available with the heat which we are using as an input to the heat engine. But that entire we are unable to convert into the work. So some work we are going to lose. So what work we can get? That is a W actual divided by W maximum, but that definition is only right for work producing device. Fine, Vikas? For a device like a fan or a bulb or any other thing, what do you need to think? What we are giving? That is electricity. Okay, that is V into I. That is the exergy we are, giving. That exergy we are expanding in that process, energy conversion process. How much exergy we are getting at the exit? Zero. Because whatever exergy we are giving, whatever work we are giving to the fan, that entire we are losing. You can ask me, sir, no, we are not losing, we are converting into the shaft energy. Okay, fine, we are converting into the shaft energy, but where finally that work is going? That entire work is going into the dead state. Why? Because shaft energy is converting into the raising kinetic energy, but we are not utilizing that energy of the air. We are not getting any work out of that. We are only getting comfort. Okay, so, but entirely at last that entire energy is going to the dead state.
Means all the available energy going to degrade.
Yes, so second law efficiency is zero. Are you getting with us?
Yeah,
second
yes.
law efficiency kya ho jayega? Zero, because whatever work we are investing, we are getting zero out of that. We are getting comfort, it's fine.
But
comfort to mil jata hai apne ko,
but no useful work that we are getting.
Huh?
No useful work at the end of the process. No useful work.
No useful work available at the end. So whatever exergy we are expending, entire we are losing. Entire is the irreversibility. जितना आप वर्क दे रहे हो, entire is the irreversibility. Because सारा का सारा ही तो आपने लूज कर दिया. What the idea? Same thing is happening with bulb also. Bulb से आपको light मिल गई, देख लिया आपने, fine. But you are getting any work out of that? No. That for that bulb also, the second law efficiency is zero. But अगर आपने उस bulb को, suppose you kept in a very small enclosure, एक बहुत ही small insulated enclosure में आपने उसको रख दिया, and you are raising the temperature of the air with that. उस small bulb को आपने use करके, what you are doing? You are increasing the thermal energy of the air.
Thermal energy of the air.
तो फिर क्या होगा उसका? फिर कुछ ना कुछ exergy होगी. फिर some exergy will get at the exit, because you can utilize that air to get some output, to get some work, because that air is now available. The air in that small enclosure, small chamber, is now available at a temperature higher than the atmospheric temperature, so you can utilize it as some kind of source. But if that bulb is there in a room and maintain that atmospheric condition, then second law efficiency will be zero. Got the difference, Vikas?
Yes.
चलो ठीक है, थोड़ा सा इसको रिवाइज करो और नेक्स्ट टाइम कॉन्फिडेंट रहना है थोड़ा सा, ठीक है? और टेक योर सफिशिएंट टाइम. दे आर गोइंग टू प्रोवाइड यू सफिशिएंट टाइम टू थिंक. और एक दूसरा, कभी भी कंफ्यूज मत करो इंटरव्यूअर को. अप्लाई योर माइंड on that specific question they are asking. Whatever they are asking, that only you need to try to answer. आप उससे डेविएट नहीं करोगे. आप उससे डेविएट करोगे, that is a negative thing. आपने 2-3 बार ऐसा किया, इंटरव्यूअर कुछ पूछ रहा है, आप डेविएट करके कहीं और जा रहे हो, वो गलत हो जाएगा. ठीक है? तो बी वेरी स्पेसिफिक विद व्हाट इंटरव्यूअर इज आस्किंग यू, एंड you need to take it very seriously कि हाँ मेरे को पता है तो बताओ. If you know, it's fine. Otherwise you can tell कि sir I don't know, this time I'm unable to recall, and sir can I guess, I'm not very sure about that, but I think sir this will be the case, this will be the answer for this. कुछ ऐसे आप उसको आंसर करो. आप unnecessarily दूसरी चीजों को हाईलाइट करोगे, then you will be in trouble. ठीक है विकास?
Yes.
Okay, good luck and keep preparing.
Thank you.